Hello, everyone. Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I'm joined by my lovely co-host,
Ben Wilson.
And today we're going to be talking about a thing that I know legitimately nothing about. So I am going to be learning along with you guys as we ask Ben scintillating and amazing questions about ML frameworks.
Hey folks, this is Charles Maxwood. I've been talking to a whole bunch of people that want to update their resume and find a better job. And I figure, well, why not just share my resume? So if you go to topenddevs.com/resume, enter your name and email address, then you'll get a copy of the resume that I use, that I've used through freelancing, through most of my career, as I've kind of refined it and tweaked it to get me the jobs that I want. Like I said, topenddevs.com/resume will get you that. And you can just kind of use the formatting. It comes in Word and Pages formats, and you can just fill it in from there.
So to start off, Ben, can you define the difference between applied ML and an ML framework?
Sure. Just to forewarn everyone, I don't claim to be an expert on them any more than anybody else who builds them and supports them. But there's a general principle of design around these things and about an approach to development that I've noticed personally. There's a big difference in how you approach these two things that you just asked about from a development perspective. So a framework is generally a generic structure of code that allows you to perform certain tasks in a way that you don't have to worry about or concern yourself with orchestration. What that means is there's some repeatable tasks that are common to a lot of applications of software. Let's say you wanted to get data from a database, and you wanted to be able to take that data and use it to fit a model and then have some sort of scoring on a holdout validation set that you could, know how good the model is. Now, without a framework, you're going to be writing the direct interface to the APIs of the library of that database. Then you're without a framework for the ML perspective, you're going to be implementing the algorithm. So let's say we're doing random forest. Well, you're going to go and look at what the components are from how the random forest algorithm works. And you're going to write the implementation about like, hey, here's how I do differential entropy calculations. And this is how I'm going to determine what the variance is. And you're going to write those equations in code. And then for scoring, that one's probably the easiest one. You're just going to run a holdout validation set through your model implementation of the scored weights, which, by the way, you would be writing all of the code for that too, to record that, store it in an object that you handcrafted, and then you would just perform the transformation through the equations based on the learned weights or the learned decision tree. And then you would write the very simple, scoring calculation of a row-wise iterator, and you would get a result. Now, 15, 20, 30 years ago, when people were doing what is now referred to as machine learning, that's how implementations were. And there's still shops out there that do that because they need to. They have some bespoke algorithm. They have a very specialized internal, data storage paradigm that there's no framework that's out there. There's nothing in the open source. And maybe the company's not big enough to have a software development team that builds a framework to interface with these different systems. So they have to roll all their own. And it's a lot of work. Now, a framework of the three things that we just talked about in the example of Python, we want to interface with the database. Well, there's the SQL Alchemy framework, which allows for a high-level API that allows you to interface with different database backends, and it will auto-generate the type of requests in that engine's, DML language, data manipulation language. It'll issue the query. It'll handle creating a cursor that you can basically open that connection to that database, issue the query, and it opens a pipe for data to be returned to wherever you're executing this code. And it handles a lot of other things. Like if you need to update data, it handles CRUD operations for you. It does a lot of the really nitty-gritty details of database management, from a non-user perspective, but more from like an engineering perspective that an end user shouldn't have to worry about. So we would use that framework. And then for data manipulation and feature engineering work, we might use something like a native Python, data manipulation framework. The most famous one that most people are familiar with is Pandas. Pandas is a high-level abstraction around messing around with data in a tabular format. And then when we want to talking about the model, if we're building a random forest, we have scikit-learn, which is a framework around these implementations of low-level algorithms that we don't have to worry about reinventing the wheel there. And then for scoring, we could use sklearn as well, or you could use many of the scoring algorithms that are in packages like stats models. So all of those things that I named, they're all frameworks. And they provide that high-level abstraction over complex code so that you don't have to keep on rebuilding that for every project. Applied ML is that project, regardless of whether you build everything yourself or you use frameworks. There's going to be a custom combination of the utilization of either frameworks or the raw implementation in order to solve a business problem. And tying that explanation into the discussion we're having today, there's a big difference in how you approach building those two things. So if you're building everything for applied ML or just applied software in general, you're thinking about high specialization to the task at hand. So if we're building this particular model and we're trying to classify whether our users are committing fraud or not, well, there's going to be specific data manipulations that we're going to do and maybe post-processing from the prediction operations that we're going to do on those results that are highly specific to the task of detecting fraud. And our code is going to reflect that because it's needed for that particular use case. Whereas in a framework, you don't build stuff like that into a framework. You might build a tool or utility that allows somebody to craft that logic in an easy way, but you don't bake into a framework all of the nuances and esoteric needs for every project that's out there.
Got it. So it sounds like a framework is like a Python package, and a not framework uses those Python packages to implement stuff. Is that more or less correct?
I mean, you could package up your project code and create a
Valid.
wheel. So it's more the higher level concept of, is this package or artifact that you're creating, this computer application, is it intended to serve one purpose or many purposes? And frameworks are meant to support many purposes in an abstract way.
Got it. Okay, so that makes a lot of sense. And an applied ML solution is just for that specific use case. It's usually not meant to generalize.
I mean, I've seen people do that. I've been guilty of that early on in my career. I'm like, well, if I build some, I'm going to create this class in this project, and it'll allow me to do all of these different things, and I'm going to make it robust to support, let's say for modeling purposes. Like, I'm going to build this interface so that I can do k-means and k-median and PCA and random forest and linear regression. But the actual project just uses a linear regression model. So I wasted 2 weeks of time building this module in an abstract way that lives within the project code, that 90% of that code is never going to get touched. It's dead code. It was a learning experience, so it was kind of valuable there, but it was a waste of time. And it's code that was getting tested for no particular reason.
Got it. So on the applied ML side, it seems like we're looking for concise yet thorough and effective solutions. So with that, as a lazy data scientist that I am, I would love to cut some corners. So maybe I don't want to write a ton of tests. Maybe I don't want to have a bunch of object-oriented structure. What are some corners that you think you can cut on the applied side that you can't cut on the framework side?
On the framework side, keep in mind that nobody's perfect. No team is perfect. No tool is perfect. Bugs happen. Test coverage is never perfect. It never will be. Things break because we're human. Well, and as frameworks grow in size, they grow in complexity generally. And the more moving pieces you have, the more probability that some use case that's out there, you're not going to think of testing it, or it's going to break in an unexpected way, which you then have to fix. But the whole concept of cutting corners with frameworks, the way to cut corners in framework development is don't try to solve all the problems. You're never going to do it. And the pursuit of doing that is going to increase complexity for your project at the sake of stability and the ability to just keep it going. Any project's going to hit a critical mass at some point where no matter how many humans you throw at the problem, how many hours you throw at it, you're never going to be able to maintain it anymore. And there are notable packages throughout history that have hit that point, and even companies start throwing tons of resources at them to keep them going before eventually abandoning it for something simpler and more sophisticated, but less complex. So from the framework side, keeping it simple and keeping the code in a testable, readable, like human readable way is paramount. Now, from an applied ML perspective, ways to cut corners is don't test framework code. You don't need to. The people maintaining the framework, that's what they already do. There are times where there's bugs that get released in any framework. There's going to be some unexpected thing. And you having a unit test in your applied framework that's testing functionality of that framework code doesn't buy you anything, because you're not going to be the one fixing it. I mean, you could draft a pull request and submit it to the open source framework package and say, hey, I have a fix for this bug that we detected last night. Can you take a look at it and merge it? That'll gain favor for you, for the maintainers. They can be like, wow, this person's awesome. They saved us from having to fix this. Great. So if that's your goal, awesome. There's better ways to test that than putting it in your application framework code. So avoiding testing functionality that's part of that core module is probably worthwhile. So if you're testing something in pandas and you're doing some manipulation, you're like, hey, I have this if conditional, I want to update index positions where this value is above this value and clean up outlier data. What you can do is take, your actual data that has outliers in it and run it through your logic for making sure that you're catching those and resetting them to the appropriate value, but limit the test to just that. So it's a pseudo integration test, sort of. It's like, hey, our raw data coming in, we know it's bad. Let's make sure that we don't, like, after we run it through this process, that our custom logic for that column conditional is doing what we want. So you're testing your if statement basically. But what you don't want to do is do stuff like, hey, after I change this column, make sure that I still have columns in the data set from before I did this manipulation. Because you're now testing pandas. Like, does pandas randomly drop columns? Yes or no? We should hope not. Because the world of Python practitioners would know that within an hour of a new version of pandas getting released. That would never happen because they do extensive testing before releasing anything. So you don't need to test stuff like that. You don't need to test, hey, I added a column. Do I still have the right number of rows? Of course you do. Pandas isn't randomly dropping rows of data when you're doing a column operation. So it's just wasted cycles of effort to come up with tests like that. And it's wasted computation, wasted time, and it's just more lines of code. And if there's one thing that I could tell a lot of people who are doing applied ML, your project's value is not related in any way to the number of lines of code of your implementation. If anything, you should be striving for the inverse of that. Strive for the fewest lines of code to solve the problem that you possibly can.
I personally strive for the biggest set of files because I like maximizing upload time. So whenever I'm committing to Git, I want it to take as long as possible. So that's the other angle. If you like working very inefficiently, just write as much code as possible. Promise you, it's super fun.
And everybody looking at your code is going to hate you.
Oh,
Because
that's so true.
when you do a PR and you look and you're like, hang on, you changed 6,500 lines of code in this PR. 3 other people, 4 other people, 5 other people, they have to read through all that stuff and make comments and try to figure out what you tried to do. It's risky, and it's a great way to create bugs.
And create enemies within your team. Okay, cool. So let me sort of see if I can break this down into layman's terms or an analogy. So frameworks are sort of, let's say we're going to build a house. That's our project. Frameworks are, let's say, the brick or the raw materials, the wood, the tile, etc., that you're going to be using. And you should have faith that those things won't crumble and break. They're the building blocks of whatever you're making, and you should trust them, and you don't need to test them. But there's a brick maker, there's a tile maker, there's a lumberjack, and all of them, it is their responsibility to ensure the quality of the component parts. So when we're building up applied models, we leverage component parts, but there are people that do have to go in and actually build those frameworks, such as Ben. So is that basically what we're talking about here?
Yeah, and if you choose not to use a framework to do this thing, we're talking about building houses in this analogy. What if you choose to not? You're like, oh, I can do the wood part by myself. Well, you now have to do all the stuff that lumberjack does. You now have to become savvy in forestry management. You have to know how to plant trees and grow them and know when to cut them, know which ones to cut, which ones not to cut. All right, once you fell it, how do you get the log off the side of the mountain? Well, you have to now know how to use all this heavy machinery to move that stuff around. Now you got to learn how to drive an 18-wheeler truck and where to take it to a processing mill. You have to know how long to dry that wood out. There's all these things that are involved in building those frameworks that are highly specific to a certain skill set. And the vast majority of people doing applied data science work or applied software engineering in general don't need to know how to do that. Just like a home builder doesn't need to know how to cut a tree down. They need to be good at using wood to frame a house. And a lumberjack is not going to come in and be like, oh, I'm going to build a house. That's why you never see like framework maintainers go like, hey, we came up with this great ML use case. It doesn't happen because A, there's not enough time in the day to do all that if you're supporting a framework. And B, it's just not, that group's speciality.
That makes a ton of sense. Okay, cool. So let's sort of switch gears a bit and start thinking about how we scope projects. And Ben and I earlier this week were chatting about this thing called Heilmeier's Catechism. It's a mess. Just Google your best estimate of how it's spelled and something will pop up. But the background of this is we were looking at the DARPA website. And DARPA is the Defense Advanced Research Projects Agency. And they have all sorts of crazy projects like flying missiles and like talking dogs and all these other things. And on the website, at least this is what I was referencing to learn about Heilmeier's Catechism, they state that DARPA operates on the principle that generating big rewards requires taking big risks. And then the question is, how does the agency determine what risks are worth taking? So George H. Heilmeier, who was like a researcher in the 70s, he crafted a set of questions that help anyone scoping a project go through and evaluate whether this program is worth it. So these sets of questions are very prominent in software. And Ben, could you name a couple open source repos or even projects that you've worked on that leverage these principles?
So these principles are at the forefront of all product decisions made at pretty much any big tech company and most small ones too. So there are the guiding principles of everything that Databricks and engineering decides to build. So you have to answer these questions before, if you have this great idea, you're like, whoa, what if we had this tool that could do this thing? If you approach a PM about that, they're going to hand you these questions and they're going to say, answer these, please. Write down your answers, and then we'll talk about it. And that could be somebody in any position within the company can propose an idea like that. And if they want to champion it and run with it, that's kind of how it's going to go. Whether you're an engineer, an executive, or anybody at the company really would have to go through this. And other big tech companies do the same thing. These principles inform, it's not just software that does this either. Other industries that I've worked in before working in software, I've seen these questions before. And I knew the story of this man's history about, his LCD display invention and how all of that revolutionized a lot of high-tech manufacturing. But the project work and focus that he was able to bring to an entire industry is, one of the reasons why he's so famous and why everybody continues to use these principles. They seem like common sense, but they're really not.
Yeah, a lot of project scoping questions do seem like common sense, but they're really, really valuable when everybody becomes aligned on the first principles and the basics. Because often people make jumps and assumptions that aren't always warranted. So, Ben, you down to walk through them and chat about each of the points?
Yeah, of course.
So, first one, according to the DARPA website, is what are you trying to do? Articulate your objectives with absolutely no jargon. So, how do you approach this type of question?
This question is written in such a way that is beneficial to everybody who's going to review the other answers to the questions. It gives a democratic approach to your project. Most people that are coming up with ideas for products to build in industrial manufacturing or software to build in our industry, they're highly steeped in jargon and technical terms that are esoteric to what they're working on. And the intent with this first question is the layman's term test. Like, can you take what you're about to write and read it to your grandparents or your parents or somebody who is completely not in your industry? Can you explain what this thing could potentially do and have the person who's making your morning coffee at Starbucks understand what you're working on? And that's critically important because not everybody that's going to be reviewing this proposal is going to have the same technical background person proposing it is going to have. So in order to get the most amount of minds and perspectives on this idea, you have to eliminate all of the specific technical jargon. You don't talk about implementation details because it's irrelevant. It's just, hey, what is this thing that you're trying to propose? Use plain language.
Exactly. And that's one thing that ML frameworks and applied ML both have in common is it should be understandable. It should have a clear value proposition. It should have a clear purpose. And that's really important to articulate at the beginning. Sometimes I have started projects without articulating this. And then 2 weeks in, I'm like, holy shit, this is completely pointless. I'm doing nothing valuable. So starting from the very basics and ensuring that everybody's sort of on the same page of what this is supposed to do is incredibly valuable.
Hey there, this is Charles Maxwood. I'm excited because I wanted to let you know about this thing that I pulled together that I've been dying to have this for years, and I never felt like I could. And then I just realized that there's no reason why I can't. So I'm putting together a book club, and we're going to read development-focused books, career books, technical books, whatever. The first book that we're going to do is going to be Clean Architecture by Uncle Bob Martin. If you're not familiar with Clean Code or some of the other stuff that Bob has done, check that out. I've also talked to him on the Clean Coders podcast, which is on Top End Devs. But we're going to get on. He's going to show up to some of our meetings. And what I'm thinking is we'll probably have 5 or 6 people part of the conversation along with Bob and I at the same time. And we'll just, so somebody can come on, they can ask their question, and then we'll just rotate people through. So we'll mute one person, unmute another person when it's their turn to come on and be part of the discussion. So we'll do that for an hour and a half. And then the other part of it that I'm putting together is just kind of a meet and greet gather area on GatherTown. And so after the meetup and the call, what we'll do is we'll all go over to GatherTown, and you can just log in, walk up to a group and have a conversation. And that way we can all kind of get to know each other and make friends and get to know people across the world. One thing that I'm finding is that, the meetups are starting to come back, but a lot of people don't have the opportunity to go to a meetup. And I really want to meet you guys and talk to you. So we're going to put all that together. It'll all be part of that book club. You can go to topenddevs.com/book club to be part of it. And I'm looking forward to seeing you there. The first book club meeting will be in December, the beginning of December. We're starting the first week of December. And you'll also be part of the conversation about which book we do next. I have one in mind, but I want to see where everybody's at. So there you go.
Cool. So moving on, the second one is how is it done today and what are the current limits? So Ben, how does that fit into this whole project scoping setting?
So there's 2 points in that are important to get an answer on from the person proposing the idea. And it's to help eliminate personal bias of the person who comes up with the idea. We are inherently egotistical creatures, humans. We think that our ideas are best ideas, right? So we have this cognitive bias of, hey, I've noticed this problem. I think I have a unique solution for it. And I think this is important. You propose it. If you don't answer this second question about how do people do this today, that first part of it, if there is no answer to that, then you're assuming extreme risk because you're coming up with something novel that nobody's doing this today. So this is a new thing that you're now gambling, basically, that whatever you're coming up with, people are going to think is valuable. And that's extremely risky. That doesn't mean don't do it. That means articulate to the people who are collectively looking at this project and its potential value that, and you have to be honest with these answers too. Like you can't make stuff up here because people are going to independently verify this by interviewing people. But if you articulate like, hey, the process of doing X is 37 steps of complex stuff, and we have this, and it's extremely needed. Like everybody has to do this thing. We want to provide a solution that can reduce the complexity of that from 37 steps down to 3. That's a pretty big value proposition of like, hey, users are going to see, hey, there's all this, and we're talking about like framework code here, but that's how a lot of new APIs are created and projects for frameworks are generated, is because people have looking at how somebody has to do this right now. And then a company just says, well, it might be internal users, or it could be, if you're a SaaS company, it could be your users who are your clients who are doing this thing. You evaluate how they're doing it right now. And you say, well, let's provide an API that simplifies this and makes it so that we can save 20 person weeks per company per year if we implement this. And any company that sees that, like, hey, this software company just released this to the open source. This saves me from doing all this annoying stuff in all my projects, and also has all of these features that we really need that we currently can't do because of time and resources. People are going to use your stuff. So that's really what this question's aiming towards, is like, hey, what's the risk of adoption here?
What are your thoughts on building versus buying?
Jeez, man. It depends. It really, really depends. What are you trying to do? Like, what problem are you trying to solve? How novel of a problem is it? And how well does, offerings that are out there solve that problem or potentially solve that problem? If there's a solution that somebody's selling, or there's an open source package out there that gets you 90% of the way there, or even 60 or 70% of the way there, that 60 or 70% can save you months of work and can reduce your test burden, complexity of maintaining this thing. But you come to the build discussion sometimes when you've exhaustively tested everything that you can. Like, hey, I've tried to solve this problem with all these open source tools. And not just me, but 7 of us on the team have tried to do this. We can't solve this with existing things. So at that point, you fill out this questionnaire for the Catechism and say, hey, do we have to build this thing, build it ourselves? How long is that going to take? How many people do we have? What's our current workload at the company? What's what's the cost of us doing this and maintaining it as well?
And yeah, that actually leads very nicely into the third point, which is what is new about your approach and why do you think it will be successful? How do you evaluate that?
This one's very important for people who haven't, up until getting to this question, done their homework of really evaluating what's already out there. So in order to answer this question, you have to evaluate other options that are available. And you should be listing down all of the things that you found. Like, well, we need this thing to do X, Y, and Z. You should be listing the fact that Y and Z can be handled with this open source package. X isn't part of that open source package, but we could couple another package with this other one and just write some glue code, effectively gluing these two frameworks together to solve this problem. What you don't want to do is do this evaluation and say, oh, we've looked and we can't find anything that solves X, Y, and Z. And then during review time, some senior engineer is looking through and they're like, wait a minute, there's this package that is part of core language in Python that does, TUV, W, X, Y, and Z. Why don't you just use that? And that review and the list of things that are purportedly new in what you're doing can help illuminate the fact that this already exists, which can save you from releasing something potentially to open source or just spending a ton of time reinventing the wheel. If somebody else has gotten there first, just use their stuff. Use your creativity in other ways.
Yeah, and moving on to the fourth of 8 total points. This is one that I have been struggling with in Databricks, which is who cares? And if you're successful, what difference will it make? Because I personally would love to build a bunch of cool stuff, but it turns out that you actually have to make money. So you need customer buy-in, you need people to be invested, you need there to be a need in the industry. So Ben, how do you go about scoping that need?
I don't. In fact, you kind of alluded to it with what you were saying about working at Databricks. We don't decide any of that stuff. We ask customers. We ask them to be, we sign non-disclosure agreements with them and say, hey, we're not going to repeat anything that you tell us during this meeting, but just, tell us if this is something that you would use. Tell us if you think this is stupid. Be completely honest with us. Or if it's an idea coming from them, we just politely listen to everything that they're saying. We take notes, and anything that's sensitive, of course, we don't take notes about, but the general concept of what they're trying to communicate to us, like, hey, we really need this functionality. We'll interview that one customer to get that first idea, and then we'll float that idea without saying that, company A mentioned it. We'll just say, what do you think about this idea to company B, C, D? And you'll talk to other companies that are within their industry in a similarly, safe manner. And if everybody's saying, yeah, this would be awesome if we had this, or yeah, we really need this, we were going to ask you about it, next quarter. So if you get this buy-in from a lot of people and they're saying, yeah, we're going to use this thing if it comes out, and here's the features that we want to see, that's that process. And that's how you answer this question. But there's times where we've had ideas that either are generated from internally within engineering, or they come from Databricks field, or they come from customers. And everybody, from a technical perspective, the people that are going to be building it, they get kind of excited. They're like, this would be cool to build. This seems like it's really important. And we go and talk to a bunch of customers, and everybody kind of looks at us like we've got two heads. They're like, no, that's stupid. Like, why would we use that? We don't get disappointed. We don't get frustrated. We just say, all right, let's do something else. Because there's always work, there's no limit. If you were to sequentially tag the backlog of ideas that are out there, there's decades worth of work to be tackled. So there's always going to be something that could replace that priority.
Got it. What % of the time are customers wrong in knowing what they want?
Man, what a loaded question. I couldn't give you a percentage at all, but let's say if a customer answered question 1 properly. And they said, and that's what we do when we interview customers for use cases. We don't want to hear about their specific needs of this one project, applying this thing. It's irrelevant. What we want to know is, in layman's terms, what is it that you're trying to do? Like, how is this solving a problem for you? And if that aligns to what we're already building or aligns to something that everybody has a common need for that use case, then that's what gets built. And we talk to them and share with them what the design is going to be. Say, hey, here's how we're thinking of solving this problem for you. And this is what it would kind of look like. So a lot of times that does happen where they have this ask that is either so specific to their industry or their company or their particular project that nobody else would be able to use. If you just list out those requirements and build to that, nobody else would ever use it because it's irrelevant to everybody else. But if you abstract out that idea of like, hey, we're trying to solve this thing in this way, and it's built in an abstracted way so that they can adapt their use case to that implementation, that's how you get successful framework editions built. And that happens all the time. In fact, it happens the other way as well. So when you're building an implementation and you're showing a prototype to a number of different companies, that's why you do private previews. And that's why you do prototype demos and request for feedback. That's that whole process. We want to know, like, does this meet your needs, or does this totally suck, or does it need this additional functionality that we're going to implement later? And most feedback is pretty brutally honest, which is how we like it. And it helps build better software.
If I'm being totally honest, I would say that beyond general technical competence and just competence in general, I would say that value scoping and identifying opportunities is the single most important thing an employee can be good at. In a prior role, I was working in decision science, and so many different people would come to you with different needs, different questions, and just be like, hey, solve my issue. And it's your job to sort of read between the lines, abstract out, and then develop more general solutions that ideally can be modularized into other areas. But people rarely know the solution that they want. They just know the pain point. And if you can gather lots of different data points, it's extremely valuable.
Yeah, I couldn't agree more. I mean, in fact, that's more important, in my opinion, than being able to effectively tune a model as a data scientist. Because you can be the best in the world at algorithm development and applied use of algorithms and how to tune them, and how to optimize your feature set to eliminate possible overfitting. All those technical skills that usually come with experience and testing stuff out. But you can be the best of the world in that. But if you can't talk to people and understand what they're trying to solve or get you to help them solve, you're just useless in a company.
Have you ever wished that you had a group of people that were just as passionate about writing code as you are? I know I did. I did that for most of my career. I'd go to the meetups. I'd try and create other opportunities, and it was just really hard, right? The meetups, I got some of that, but they were only like once or twice a month, and it was just really hard to find that group of people that I connected with and really wanted to, talk about code a lot, right? I mean, I love writing code. I think it's the best. And so I've decided to create this community and create a worldwide community that we can all jump in and do it. So we're going to have 2 workshops every week. One of those or 2 of those every month are going to be Q&A calls, right? Where you can get on, you can ask me or me and another expert questions. The rest of them are going to be focused on different aspects of career or programming or things like that, right? So it'll go anywhere from like deployments and containers all the way up to managing your 401k and negotiating your benefits package. We'll cover all of it, okay? And then we're also going to have meetups every month for your particular technology area. So we have shows about JavaScript, React, Angular, Vue, and so on. We're going to have meetups for all of those things. I'm going to revive the freelancer show. We'll have one about that, right? So you can get started freelancing or continue freelancing if that's where you're at. And I'm working on finding authors who can actually do weekly video tutorials on something for 10 minutes that's related to, again, to those technology areas so that you can stay current, keep growing. So if you're interested, go to topenddevs.com/sign up. And you can get in right now for $39. When we're done, that price is going to go up to $75. And the $39 price gets you access to 2 calls per week. The full price at $150, which is going to be $75 over the next few weeks, that price is going to get you access to all of the calls and all of the tutorials and everything else that we put out from Top End Devs, along with member pricing for our remote conferences that are coming up next year. So go check it out, topenddevs.com/sign up.
So we have, I think, 4-ish more, but we're just going to skip to the last one. If you guys want to review them on your own, feel free. But the 3 that we're going to be skipping are: what are the risks, how much will it cost, and how long will it take? All of them are about identifying potential issues and bottlenecks and are essentially a reason to not do the project or be wary as you go through the project. But one thing that I want to ask Ben about is this specific question. What are the midterm and final quote unquote exams to check for success? So as you're developing this project along the way, how should you think about measuring whether you're on track? And at the end of it all, how should you determine whether you have succeeded in implementing the solution?
I mean, for software, this was one of this sort of several defining principles that informed agile software development, which is so the industry that this guy came from, originally before he started working for DARPA, working for RCA Labs in Princeton, New Jersey, and is working on, electrical engineering tasks, specifically for displays. Invented a bunch of super cool stuff. But when you're talking about inventing a new technology and building prototypes, that's just like how software used to be built, because people that were building software 30, 40 years ago came from physical engineering backgrounds. They were electrical engineers who were like, oh, I can now use a computer to do this thing. It's kind of how that industry got started. And when you approach a project in software like that, it's called waterfall development. And you gather a list of all of your requirements up ahead of time. You spend a lot of time building all of this stuff to meet all of those requirements. And at the end of construction of your prototype, you send it out for review. People evaluate it, test it, and that's kind of that midterm check. And once everybody agrees that all of the subsequent repair work that's done to it or adjustments to that software are done, then you send it out for a final review, which is that final exam. And you get an acceptance or rejection of it. Waterfall's super dangerous in software. People have known this for many, many decades now. So nobody really does that anymore. Although, I have seen companies do it with applied ML and applied data engineering tasks. It's not recommended. So instead, in agile development, you have this principle in your mind of constant exams. So instead of saying, hey, we're going to build this thing that does these 127 things, and we're going to make sure that all 127 features are built out before we show it to anybody and it's complete. That's really risky, because what if half of those are totally useless, 10 of them are broken, and then you failed to build 15 things that people actually care about, so nobody's going to use your stuff that you built. So the agile process of constantly doing checks of, hey, I have a new feature, we're going to release a candidate for this, we want people to test it out, we do our own internal testing. This week, while we're chatting right now, last week, this week, and next week, and you were a part of it earlier this week, where we did dog fooding, which is a software development term for eating your own dog food, like testing out your own code. We're working on MLflow 2.0, and we're having people test our release candidate build and telling us, hey, tell us how this is broken and we'll fix it. And we don't do that just for the 2.0 release. That's done for the 2.0 release. It's going to be done for the 2.1 release and the 2.2 release. And it's never ending. And when new features are proposed and implemented, we're testing that out. We're making sure that it behaves right. It might need adjustments later on. We might have breaking changes later as the project evolves over time. So it's really important for that final question when following this for product design, particularly for ML as well, is understanding that this is a mutable thing. Your project is not just done when you release the first set of predictions. You could be rewriting that entire project from scratch 5 times over in the first 2 years. Like every line of code could change. It's not the code that's important. It's the problem that you're trying to solve. Nobody cares how you solve it. Nobody cares how pretty your code is, or how sophisticated the algorithm is that you're using or that you've implemented. It's the project that matters. And knowing that every time you're going to have a new idea to solve or a new change to make is thinking about, are we successful at what we set out to do? How are we validating that?
Yeah, and if you're curious whether you will have tendencies to stick to projects too long, ask yourself if you're okay with stopping books mid-chapter or even mid-sentence. Lots of people, such as myself, really want the satisfaction of going to the last page, closing the book, and being like, I'm smarter because I read a book. It's actually a lot better if you spend your time doing the right books instead of completing the wrong books just because that's what you picked up. Cool. So I'll quickly summarize. So applied ML is sort of for a single use case, and you typically leverage frameworks as much as possible and rarely build very low level operations or applications. ML framework code instead are design patterns that are used to make writing code easier for multiple use cases. So they're very modular, and it's paramount to make them readable, well-designed, and quote-unquote specific. They should solve a problem and solve it very well instead of kind of solving many problems. And then a couple tips when leveraging these frameworks and just scoping an ML project. Make sure that you are actually scoping the value of the project and ensuring that there are customers or consumers on the other end of it. And Heilmeier's Catechism can help a lot. And then another point is it's important to have humility in your knowledge of what the user needs, but don't take their ideas as fact. So listen, but try to read between the lines and figure out what their actual pain points are instead of forcing your ideas upon them. Anything else, Ben?
Oh, it's a perfect summary.
Beautiful. All right. Well, until next time, it's been Michael Burke.
And Ben Wilson.
And have a good day, everyone.
Take it easy.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.